Hello everyone, I am Pushpata. I am pursuing Masters from IIT Hyderabad, and today I would like to discuss a very important organometallic reagent reaction, which is a Grignard reagent reaction. So it is represented as RMgX. R is any alkyl or aryl group. And magnesium is in +2 oxidation state, and X is any halogen, mainly chlorine, bromine or iodine. So first I would like to discuss its preparation, and then we will come to the reaction part. Now RMgX, how it is prepared. So first we will take alkyl halide reacted with magnesium, 0 oxidation state, in presence of ether, gives RMgX. So this alkyl halide is reacted with magnesium and gives RMgX as a reagent product. In this we have reacted magnesium with oxidation state 0, and after the reaction the magnesium state oxidation state increases by 2. So this reaction is known as oxidative insertion. Insertion of what? Magnesium. So this is the general scheme for its preparation. Now it is not necessary that every alkyl halide will prepare this reagent. If, for example, if we take 1,2-dihalogen or 1,3-dihalogen group, X1, X2 are the halogen reacted with magnesium in presence of ester. Now this will freely form MgX1, X2. This will form, but immediately this bond will break and negative charge will form here and will eliminate this halogen and gives formation of alkene. In case of 1,3-dihalogen, this will form, this bond will break and negative charge at the carbon, and this negative charge will attack this position to eliminate this and leads to the formation of cyclopropane ring. So what we have to notice is that it will react with alkyl halide and will give the product as. Now let's discuss its reaction part. First, reaction with carbonyl groups. In this we will study ketone and aldehyde. Now first let's discuss why heat. This carbonyl group, it's a very electron deficient center, because this O is very electron negative and it will withdraw all the electron density towards it. So this carbon will be electron deficient and will act as a electrophile, means electron loving. Now let's take example. For aldehyde, so this magnesium acquires positive charge and negative charge, and this bond weakens and will dissociate, and R negative will act as a nucleophile. Nucleophile means nucleus loving. Here electron density is much more, and here electron density is, and this R negative will attack at this electrophilic center and gives R1 O negative, which further reacts with water and gives 2-degree alcohol. Now let's take the example of ketone. Same RMgx, this R negative will act as a nucleophile, shift the electron density towards oxygen and gives R negative, further react with water and gives 3-degree alcohol. 2-degree alcohol means this carbon is attached with 2 different carbon groups, and this is 3-degree means 3 carbon groups here. So now let's take the example of esters. With esters, the first thing we have to make clear is that the reagent must be in excess amount. Why in excess amount? Let's see. Now let's take an ester group. React with R MgX. This R will come out as R negative and will attack at the carbonyl center and gives now this negative charge will come back and eliminate this group. And further it will transform into a ketone. Now again react with RMgX. This R group from reagent attack on the carbonyl center and further reacted with water gives this R negative will react with proton from the water and yield a 3-degree alcohol. So here we have noticed that we have used this reagent multiple times, like 2 times I have taken this reagent, which leads to the alcohol group. First it convert into the ketone group and then in alcohol group. Now third reaction with acid chloride. Let's take an acid chloride which reacted with RMgX. Again R will come out as a R negative. Attack at the electron deficient center, which is our carbonyl. And this negative charge comes back and eliminates this chlorine, which yield ketone as our main product. Now third, let's take a epoxide group. Reacted with RMgx. This R negative. Now question comes where it will open the ring. From this side, it has two possibilities, from this side or this side. So here steric factor also comes in the picture. This R negative will not attack at this position but this position. So here, now this ring will open from this side. So this will attack, this will have this O negative, and at this carbon position our R negative will come. Further reacted with water gives ROH, and alcohol gives an alcohol product as the main product. इसको ना पॉज कर देंगे क्योंकि अब मैं समराइज करूँगी ना तो ये रब करना पड़ेगा पूरा. हो गया मेरा रिएक्शन पार्ट. Now to summarize the reaction part, this is our reagent. When reacted with aldehyde gives, include water also, gives 2-degree alcohol. When reacts with ketone gives 3-degree alcohol. Now when reacted with esters, in excess amount, gives 3-degree alcohol. Notice both the alkyl groups will come from the reagent. Now third, we have discussed the ring opening of epoxide. Which also gave us this 2-degree alcohol. And third, the last, with acid chloride, it yields a ketone. So I have summarized all the reactions which we have discussed in this topic. Thank you.